Okay, here I've got a JupyterLab running on my EC2 instance, and we're going to get started with this infrastructure limitations experiment. So basically, we've got two questions that we're going to try to answer here. One is what size data set is too large for a T2 micro to load into memory, and the other is what size data set is so large that on a T2 micro it will prevent Jupyter from fitting different kinds of simple machine learning classification models, for example, k-nearest neighbors or decision tree or logistic regression. So the whole purpose of this is to get a sense of resource consumption when we're running Jupyter via Docker on an AWS T2 micro. I'm actually going to make this a bit bigger here. So I'm going to actually scroll through this section here because we've already got this configured and running. This is instructions for deploying Jupyter using T2 Micro on AWS. We're going to get right down to getting started with the experiment. So I currently have a connection to my server right over here. I've got tmux running here. And we've got nothing running in this cell. I can issue commands. So no active processes. I'm able to type commands. I can type pwd and check this out. I can clear it and get back to here. So what we're going to do to get started is we're actually going to run this docker stats command. I'm just going to copy it here from the Jupyter Notebook, and this is going to give us a sense of what processes are currently running on the system via Docker, and how much of the CPU they're consuming and how much of the memory they're consuming. So we have a single process here. It is the Jupyter container, the Jupyter Notebook server, and it's using this much of the CPU and this much memory. So even just at rest right now, we're not really doing anything. The Jupyter is consuming 110 megabytes of the almost 1 gigabyte of RAM. So this memory here is referring to RAM. This is referring to CPU. All right, so the other thing that we're going to do is we're actually going to also write the output of this docker stats command to a file. Now, I can't do it in this shell because this is connected to an active process displaying the docker stats. So I actually have to make a new tmux window in order to display this. So the way I'm going to do this is Control B, C. To create, C for create a new window. And you can see that now I've jumped over here to a new window. I'm on 1, so the little star right here is next to the 1. And so this is I have a new window, and I can issue the command here. There it goes. So that's actually running right now. And again, this is also an active process, so I can't type anything here either. If I want to type anything, I have to create a new one. So Control B, C to create a third tmux window. So the first window now, Control B N to show it, Control B N for next, shows the first window. This is where I'm looking at the docker stats process. Control B N for next. This is showing where the docker stats are being written to a file. In this case, a file named statsexperiment-1.txt. And Control B N. This is the available process. There's nothing, or this is the available bash session. There's nothing running here, so I can actually type commands. I can do ls-l to show what's in this directory, and you can see that all I've got here is the statsexperiment-1.txt file. So let's actually, while we're here, let's do Control B N to jump back to the first tmux window, and I'm actually going to resize this to bring it up here. So this is sort of running at the top of my screen. And then I'm going to resize my Chrome window here where I'm running Jupyter, so I can kind of have both of them running at the same time. So I can look at Jupyter down here and look at the docker stats command up here and sort of have a dashboard into the processes while I'm running them. So we've got we're actually gonna, the purpose of this is to create different data sets and to load them and have a look at the resource consumption while I'm loading these different data sets. So the data sets are all going to be of different sizes. These are the sizes of the data sets. So the first number is the number of rows in the data set, and the second number is the number of columns. And what we're going to be trying to do is see which of these data sets, when I load it, causes an error. So causes the error we're going to see is a memory error. So which of these data sets, when we load it, is going to cause Jupyter to run out of memory. So it only has 1 gigabyte of memory available to it. So one of these is going to be so big that it can't fit in memory. It has more than 1 gigabyte of substance to the data set, more than 1 gigabyte of data. So that's what we're looking at here. So we've got an experimental process for this first experiment. So I'm going to start Docker stats and capture the output to stats experiment-1.txt, and I've actually got that already running in the second session up here. Then we're going to create each data set and pickle each data set, and then remove the data set from memory, after which I restart the Jupyter kernel. So that's the process that we're looking at for conducting this experiment. So I've actually got some helper code to do that, and this is what the helper code looks like. It's in a file that we have on the system called infrastructure-test.py. You can actually see it. It's right here. If you go back to the top level, it's in the lib directory right here. There's infrastructure-test.py. So that's the file that we're going to be using. I've got the code pasted here in the notebook as well so that you can look at it. So we're importing some different packages that we need. It defines a function called make and save dataset, which takes an n, or a number of rows, and a p, or a number of columns, and then a dataset, which is a string. It's going to be the name of a dataset we're going to load. And so we're actually going to use the make classification function that's part of the sklearn.datasets package. So we're going to run the make classification function on an n by p dataset, which returns features and target of the appropriate size. So the features are going to be an n by p array of data, and the target is going to be a vector of labels of length n. And so I'm going to save both of those with the name features, it would be features 1 and target 1, features 2, target 2, with using the variable dataset as part of the name. I'm going to sleep for 1 second, and the purpose for this is to sort of hold for a second after we've done the creation so that it will register properly for the output. So we'll have at least 1 second of time holding that data in memory so that it'll show up on our data collection, and then we're going to close the process and restart the kernel, and that's going to be how we're going to conduct each experiment.